Formula One's famous brake-by-wire systems were introduced together with the revolutionary 1.6L V6 turbo powertrains back in 2014. These rule changes allow the recovery of 2 megajoules of energy per lap through the rear brakes, with a total of 4 megajoules of energy per lap transferred from the energy store to the drivetrain during acceleration, equating to around 160 bhp for 33 seconds each lap. To achieve this, the braking system has 2 hydraulic circuits, with a separate master cylinder for the front brakes, and another for the rear. The front brakes operate conventionally, where the driver pushes the pedal with a force of 160 kilograms, applying pressure to the fluid in the master cylinder. This fluid is used to actuate the 6 pistons within the front calipers, which clamps the brake pads to the carbon disc, reducing the speed of the wheels through friction. The rear brakes, however, have an additional master cylinder which is electronically controlled. Therefore, during braking, fluid is moved through the rear master cylinder as normal. However, the MGUK then determines the amount of pressure applied to the rear calipers. In this way, the energy from the rear brakes is recovered, but once the 2 megajoules limit has been reached, the rear brakes operate conventionally. For further details on Formula One brake-by-wire systems, see the following articles. 2014 F1 Explained. What is brake-by-wire? 2014 F1 Explained brake systems. Back to top 2. 2017 regulations. This year's tires are 25% wider than 2016, with the fronts increased from 245 mm to 305 mm and the rears from 325 mm to 405 mm. Despite the rim size remaining at 13 inches, the tire diameter has also increased slightly. The target of the new regulations was to increase downforce levels by around 30%. This is why the front wingspan has increased in width from 1,650 mm to 1,800 mm, and the overall width of the car is now 2,000 mm rather than 1,800 mm. The height of the rear wing has reduced by 150 mm, with the diffuser becoming both wider and taller by 50 mm, and now extends ahead of the rear wheel axle. This combination of the wider tires and the higher downforce has increased the torque at the wheels by 20%, demanding more performance from the brakes compared to last year. Back to top 3. 2017 brake discs. To cope with this increased torque, the front carbon brake discs have increased in thickness from 28 mm to 32 mm. However, due to the brake-by-wire system, the front axle experiences the most braking performance, approximately 60% brake bias, and so the rear discs have reduced in diameter and thickness by approximately 7%. The wider discs also allow for improved cooling, which is essential when the friction on the discs can generate temperatures up to 1,200 degrees Celsius, which is similar to the temperature of molten lava. To dissipate this heat, the carbon discs have ventilation holes that are between 2.5–3.0 mm in diameter, and the number of holes is inversely proportional to the diameter of the disc. With each circuit demanding different performance from the brakes, Brembo supply 3 types of discs, each with a different level of cooling to suit particular tracks. For example, the low cooling discs only have 500 ventilation holes and so would be used at Silverstone, Spa, Sao Paulo and Suzuka, where the average braking demands are relatively low. Whereas, Singapore, Monza and Canada require a lot more performance and so would use the high cooling disc, with 1,300 ventilation holes. Maintaining the brakes within the optimum temperature window is one of the race engineer's main challenges, and is a balancing act. The pads and discs need to be hot to give the brakes bite, which is why at the start of most races, when the brakes are cold, drivers often struggle around the first few corners, until the brakes are up to temperature. The heat generated from the brakes can also be used to increase tire temperatures via complex air ducts. However, it's also important to keep the brakes cool, as this slows the rate of wear. It's very important for teams to experiment with the setup of the car during FP1 and FP2 to define the optimum working range of temperatures for the brake discs and pads. If initial temperatures are too low, under 250 degrees Celsius, then the drivers can glaze the disc, which decreases the life. However, if temperatures are too high, above 600 degrees Celsius, then you can have high wear, says Andrea Pellegrini, Brembo F1 engineer. They also have to keep in mind that during the race weekend, brake temperatures will continue to increase due to track evolution and also at the start of the race when the car is heavy with fuel. Therefore, the engineers need to continually adjust the margins of their defined temperature window. Back to top 4. 2017 brake calipers. Formula One calipers are now so intricate that they can take up to 40 hours to machine. The aluminum lithium monoblock calipers are now larger, each weighing an extra 300 grams, as the wider tires allow more space for the inner wheel assembly. Again, due to the forward brake bias, the rear calipers are smaller, operating only 4 pistons as opposed to the 6 pistons used for the front calipers. Each team's braking system differs from the other as every driver's preferences are different, and so is the team's design approach. Every team has a dedicated front and rear caliper design because some teams prefer stiffer, but therefore heavier and larger calipers, and there are other variances in terms of the weight of the rim and the installation. Stiff calipers and an overall stiff system gives consistent feedback to the driver from the beginning to the end of the race, but of course this compromises the weight, highlights Pellegrini. There are some drivers that prefer braking with a long pedal, and so require shorter master cylinder travel, and others that drive better with a shorter pedal. Therefore, the size of the master cylinder is also different between teams, but the carbon discs are usually the same. Back to top 5. 2017 brake pads. The pistons in the calipers apply up to 5 tons of pressure onto the brake pads, which is why this year's carbon pads have increased in width by 2 millimeters. Normally, brake pads would only be suitable for one entire race, however now they can endure up to 800 kilometers, so can be used for another practice session. Of course this depends on the severity of the circuit. Back to top